Okay, welcome back everyone. So in this lecture we are going to create two programs. One will be the server which will be listening for incoming connections, and the one will be the client that will be trying to connect with our server. So our server will be our hacker which will try to communicate with our victim, which will be the client machine. So our client will be this Windows 10 machine and our server will be this Kali hacker machine. So what we will try to do is we will try to get a reverse connection. So a reverse connection is a connection that is established from the victim to the server to the hacker, instead of hacker trying to connect with the victim. Because if the hacker tries to connect with the victim, the intrusion detection system or the firewalls usually block this connection, so the hacker cannot directly connect with the victim. But if we somehow enable the victim to connect to us, we can get access to his machine, and then we can do further post exploitation. So first we will create a server.py, and alongside we will create a client.py. So this will be listening for incoming connections, and then this program will try to connect with our Kali machine. So I have created a folder called hacker server, and inside it I have an environment enabled. So you can see that. Let's enable it. Source venv pin and activate. So now we have the environment enabled, so I'm going to clear it. Okay, similarly we have, let's open a terminal. Okay, so now the next step is to write the server program. So in order to write the server, we will first import a package or a module called socket. This is a built-in Python module, so you don't have to install it. Once you have it, you will require certain things in order to connect. So first thing is you want to know the server IP. So this is the server machine, and in order to know the server IP, you can write sudo ifconfig and then enter the password, and you can see that we get this IP. So I'm going to copy it, and I'm going to create a variable called server IP, and I'm going to paste it here. Then you have to create a server port variable. So this will be the port number that we will be listening to. So this will be of type integer. So I'm going to listen on port 8080. Once you have that, we will start creating our program. So I'm going to create a main. So this whole line tells the compiler to start execution from here, so it knows that the main program starts from here. Okay, first we will create a socket object, and then we will create a listener. So in order to create a socket object, we can use socket.socket, and then we require certain parameters. So the first thing is that we want to create an IPv4 communication, because we want to create a TCP socket, and this TCP socket will work with IP addresses of type IPv4. So if you know networking, you know what a what an IPv4 or IPv6 address is. So this address is IPv4. It's a 32-bit number. So first we will provide this. So we can say socket.af_inet. So this tells the compiler to select the IPv4 version, and then we can give another variable .sockstream. So this tells the compiler to use TCP streams, and then this is going to return an object called let's call it sock. Okay, once we have created this socket object, we need to bind it with this server IP and server port. So in order to bind it, we can simply say sock.bind, and then we have to provide the address. So the address would be the server IP and server port. Once we have bind this IP with our socket, the next step is to simply listen. So we can say sock.listen, and then we have to provide some parameters here. This requires a backlog. Backlog means that you can see that it requires a backlog. So backlog actually means how many connections it can put in a queue before it starts disconnecting clients. So for example, if you have 5, backlog as 5, so it will queue 5 connections, and if there is a 6th connection, it will drop this connection. So we will put 5 here, or you can put 1 here, it doesn't matter. Okay, now we have created a listener. So now our next step is to accept this connection. So we can say sock.accept, and this will return the client socket and then the client address as well. So client address. So first we can say that let's put a print statement here which says that waiting for incoming connections, and then we are waiting on server port. So this will be the server port that we will be listening on. Once we have this socket, we will send some message. Once we have accepted the connection, we will try to send a message to our victim machine. So let's say I create a message, and message will be, this is the server speaking, and then we have to send it. So we can say client sock dot send, and this is a string, but we can send bytes. You can see that it requires data in bytes format, so we can say message dot, and you can see that we have an encode function. So we can call this function and it will convert this string into bytes. So now we have sent the message. The last step is we simply have to close this connection. So we can say client socket dot close, and this is same as file handling. So if you open the connection, you have to close it. So now we are closing the connection here. Okay, so now our server program is complete. It will try to listen on incoming ports, and then it will try to accept the connection. Or we can also, let's cut this here, put it here, and we can also put the client IP here as well. So we can say client underscore address. So we'll print both the client IP and client port, the listening port as well. Okay, so that's it. In next lecture we will try to write the client. Okay, welcome back. So in our previous lectures we created our server program that was listening on for incoming connection. Now we will create a client program or a victim program. So I will use these terms interchangeably. So server and hacker will be the same thing, and client and victim will be the same thing. So now we will start writing our client. So first I'm going to import the same module which is called socket, and then we will define our server or hacker IP. So I've created a variable called server IP. So in order to get this IP, I can open a terminal and I can write sudo ifconfig, and it requires a password. You can see that we get this IP. So 192.168.29.132. So I'm just going to copy it and going over to the Windows machine and pasting it here. Now we need the server port that we will connect to. So the server port will be 8080. The next step is to start the programs. So some of the program is going to remain the same, so I'm not going to spend a lot of time explaining it. So main. So now we will create a client socket. So let's call the module socket.socket, and then we are going to use the same IPv4 socket. So af underscore inet, and then we are going to use the same sock stream as well, and then we are going to store it in a variable called sock or socket. So once we have this socket, we will try to connect with this server IP and on server port. So in order to connect it, what we can do is we can use sock.connect method. And if you go to the documentation, you can see that it requires only one address, which is an address which is essentially a combination of the server IP and the server port. So it requires this address in a tuple form. So I can create a new variable called address equals to, and then I'm going to create a tuple. So the first one would be the server IP and the second one would be the server port. So now I can simply pass this address here. So as you can see that I only passed one element here, which is this tuple. So I made the same mistake in my previous program. So if I go to the server, instead of passing these as separate parameters in this bind function, just create a new tuple called address and then pass this address here, which is in bind method. And then there was another small mistake. So I wrote this waiting for incoming connection after this accept method, while in fact it should be before this accept method. Once this method has accepted the connection, you can print out the client address here after this line. So anyways, let's go back to our client machine. If you go to the calling machine again, you can see that we are sending a message to our victim. So the victim has to receive it. So everything, if you send something from one machine to another, on the other machine you must accept it, otherwise this would cause an error. So here we will receive this. So we can say that message received equals to, and then we can use the same sock object. So we can say sock dot, and then you can see we have a method called receive, and this receives the different number of whatever you send from the server machine, it will receive it here. But first it has, if you go to the documentation, you can see that it requires a buffer size. So it must know what the buffer size is, or how many bytes should it read from this connection. So let's say if we write it 1 here, so this is only going to read 1 byte. So this will only print out this T in this message, but we don't want to do this. So let's say we just want to read 1 kilobyte of data, whatever is sent from the server machine. So in order to do it, we can create a new variable called chunk size, and then let's create it of size 1024, which is 1 kilobyte. So we will pass, instead of 1, we will pass chunk size here, and then simply we will close this socket. So before actually closing it, let's just print this message. So if you check the documentation, you can see that it returns, click on documentation, it will take some time. You can see that it returns a data which is essentially a stream of bytes. So this message received is in the form of bytes. So in order to print it, we have to decode it into strings. So we can say message received dot decode method, and this will convert it into strings. And lastly, we simply have to close the socket so we can get a new connection, so that we close the connection properly. So now our client program is complete as well. So the last thing we need to do is, let's clear this out here. So now we can call this Python server program, and you can see that it says waiting for incoming connection. So it prints out this line, which is the server waiting for incoming connection, and the server port, which is 8080, and then it is waiting here for the incoming connections. So now whenever a client or a machine tries to connect with it, it will accept the connection and it will move forward. And then if we go to the Windows machine and run the same program here, so we can say python client.py, and you can see that now it prints out a message called this is the server speaking. And if you go to the server machine, you can see that it says this is the server speaking. So in this way we can successfully print out the message. So let's change the chunk size here. Instead of 1024, let's print out 10. So let's try to run this program again. Okay, so this socket wasn't closed properly, so sock.close. So I didn't close this socket properly, so it is now using this address, so it will take some time to release this port. So let's try again. It usually takes around 30 seconds I think to release the port. So let's wait for 30 seconds. Okay, so now it has released this port and now it is waiting for incoming connection. So if I try again, you can now see that this does not print the whole message, it just print out the first 10 bytes. So 1 2 3 4 5 6 7 8 9 10, and you can see that it only prints out the first 10 bytes. So in this way you can send data, or you can see how to send or receive bytes. So this is a very basic example of how clients and server can communicate with each other. So this has no hacking aspect. So this is generally how even the normal TCP connections in Python are executed. So in next lecture we will take this example as our basic framework, and we will try to build our whole module on top of this function. Okay, see you in next lectures. Alright, so welcome back. In our previous lectures, we created a server and a client and tried to communicate with them. So in this lecture, we are going to create a more organized program, and then we will start building our remote access tool on top of it. So here our goal is to create a program that will allow us to achieve certain tasks on our victim machine. For example, it can help us to, for example, let's say run commands on the remote system. So you give the commands from the server, and these commands are executed on the victim machine, and you get the results back to the server or hacker machine. So similarly, you will be able to download or upload files to your victim machine. Also, you will access some other features as well, which we will develop as we go along. So the first goal is to create connection. So we will create a class called server, and then we will also create a class called client connection. And these classes will help us to create connection. So instead of writing as a main program, we will create classes so that we can use it later if we need them. And this is a more Pythonic approach. So I have created a directory in our main project folder called core, and in this directory I have a file called connection.py. And now we will start developing this connection.py. So the first thing we need to do is we will import socket. And once we have imported socket, we will create a class. So I'm going to call it server connection. And then we will create the constructor here. So it should be _init, and it will contain a self call. And then we will create the socket here. So we can say socket.socket, and then we will call the socket.af_inet, and similarly we call the sock stream as well. So socket.sockstream, and then we will initialize this into a variable called self.socket. So now this whole connection is, our socket is associated with this class. So if we call an instance of this class, this socket will be created automatically. Okay, so the next function we are going to create is called, so let's create the documentation here as well. So instead of like this, so I'm going to create the documentation as well. So summary creates a socket, creates a TCP socket for server. Okay, let's fill it here. Okay, so now we will create a function called create connection. So this will take the IP address and the port, and it will try to listen on this incoming port. So we will call this function as create connection, and then it will take self and also the IP address. So by default we set the IP address to the local IP address. So if you leave the string empty, it means that when you call this function here, which is server.bind, if you leave this as empty, for example server IP as empty strings, it will by default take system's IP address, so you don't have to give the value here. And then it will take in the port number. So let's, by default we will select the port 8080, otherwise if the user gives an port number we can change the value. So the next step is to, if you go to the main file, so first we create a socket and then we bind this socket to this address. So now we have to bind it, so let's call it self.socket, and then we have to bind it. So in order to bind it, we can call the bind function here, and then we require the tube address here. So let's call it self.server IP equals to IP, and similarly self.server port equals to port, and then we will give these values here. So we want to give this as a tuple, so I'm going to create a new variable called address equals to, and it would be self.server IP and self.server port, and then we can give the address here, so self.address. So now we have a connection complete. So if we call this function create connection, it will create the connection and bind this socket with it, or the IP address with this socket. So that's it for this lecture. In next lecture we will create more functions and proceed further. Okay, so now we have bind this address with our socket. So our next goal would be to listen for incoming connections, and if there is a connection we have to accept this connection. So now we will create these two functions which will listen for incoming connections, and if there is an incoming connection it will accept and return this client socket and client address. So let's create a function called listen, and it will take self as an argument, and then if you want you can set backlog as well. Let's say backlog to 5, and now we will use the same socket, so self.socket.listen, and we will give the backlog here, and this will start listening. Then we will create a method called accept connection, so it would be def accept connection. It will take self as an argument, and then it will return the client address, or it will return the client socket. So we can say self dot connection or self dot socket dot accept, and it will return two things. So first one would be the self dot client connection, and the other one will be self dot client address, and then we can return these two values from this function. So I'm going to call return, and I'm going to return this as a tuple, so self dot client connection and self dot client address. So now we have these functions set up. So in next lecture we'll proceed further. I'm going to stop here. Okay, so once the connection has been accepted properly, our next goal would be to define methods that can help us in sending and receiving inputs. So now we will define a method that will get the user input, and then it will try to send this input to the client machine. So first we will create a method called send data, and it will take the argument self and then the user input, whatever user inputs. So now the user input will be in the form of string, so in order to send it we have to convert it into bytes form. So Let's convert it into bytes. So we can say user input in bytes, and this will be equal to, we'll typecast it to bytes and then provide the user input as an argument and then the encoding. So we will use the common UTF-8 encoding, and then simply we will call the send function. So self dot client connection dot send, and then we will send the user input, which is in form of bytes. So that's it. Now we are able to send data. And similarly, if you want to receive data, you can create a method called receive data. Sorry for my typing mistakes. So it will be received data, so it won't take anything, and simply whatever you give it, it will receive it in the form of bytes. So we can say self dot client connection dot receive, and then you have to give the chunk size. So let's create a constant variable here called chunk size, and let's call it 4 KB. So I don't want to 1024, so this is 4 KB. So I can put chunk size here. Now this will receive the data, and we have to store this data in some variable. So I'm going to call it receive data, and this is in the form of bytes, so I'm putting bytes here, and then we have to decode it into string so we can read it properly. So I can create a new variable called self dot data equals to receive data bytes dot decode, and then we will use the UTF-8 decoding as well. And similarly, we will do the same process on our client side as well, and then this is going to return this data. So now we have a basic skeleton setup. In next lectures we will proceed with the client side. Okay, so now I am on the client side and I have created a file called connection. So in this file I have created the same class called client connection. I initialized it with sockets, so it's IPv4, and then I created different methods. So the first method is called connect, which takes in the server IP and server port, and then it tries to connect with the server using this IP and port. Then I copied the same function that I created on the server side, which is send data and receive data. So this takes a string and sends it as bytes, and this takes and receives bytes from the sockets and returns it in a string format. So go ahead and create this function. So it should be pretty straightforward. Okay, in next lecture we will try to create instances and run these. Okay, so now we will create instances of client connection and server connection, and then we will try to communicate the data and see if everything works properly. So first we have to import the client class into our program. So we can import it using from core.connection. We can say import server connection, and then we can call if name equals to main. Okay, so now we can call this function or call this constructor. So we can say client connection, and then we can store it in a variable called my socket or server socket, whatever you like to call it. Then we have to provide the IP address and port. So I'm going to use my socket dot create connection, and then I'm going to pass the IP. So since I want to use my local IP because it's a server, I'm going to pass empty strings, and then I'm going to pass the port number, which is 8080. Okay, then we have to listen for incoming connection. So we can call the listen function, and then we have to call the accept function, because once we are listening we have to accept connections. So I'm going to call my socket dot accept connection, and this is going to return a new connection called my connection. and it is also going to return the client address, but I'm going to ignore it because I don't really need it. And once we have it, we can simply send the data. So I can say mycon.send or mysocket.send data. Note that if you go to the connection, you can see that send data is using client connection to send the data, not the socket, which is this one. So this is just an instance of server, and then we have to pass the data. So I can say, hi, this is server, and similarly we can check if we can receive properly or not. So you can say mysocket.receive data, and then I'm going to print it. The last step is we have to close this connection. So I didn't really define the function here, but what I can do is I can say my connection dot close, and similarly I can call my socket dot close. No, I didn't define it, so my connection dot close should work. And now we will go to the client side and do the same process here. So I'm going to copy something. Okay, so let's just copy this one. So first we have to import it. So I can say from core.connection import client connection, and then I'm going to paste this line. Then we have to create the client instance. So I can say my socket equals to client connection, and then we can connect. So it should be socket my socket. Now I want to connect it, so I can say connect, then provide the arguments. So the server IP is 192.168.0.32 and the port would be 8080. And then since we are sending data from the server, we have to receive data here. So I am going to say my socket dot receive data, and first I am going to print it. And then it should be print. And then I'm going to send data from my client to the server. So I'm going to call my socket dot send data, and hi, this is client. So that's it, our programs are complete. So now we have to simply run it. So I'm going to call python main server.py. Now it's waiting for incoming connections, and if I go here and run python main client.py, so what is the issue here? Cannot concatenate string. Okay, so I made a small mistake here. So this client is on line 23. So this port is the string. This port is int, but I wrote it as a string, so I have to first typecast it. So now it should work. And if I try it again, so now you can say that it says hi, this is server. And similarly, if I go to the victim or hacker machine, you can see that it says hi, this is a client. So we have successfully established connection between both the devices. So in next lecture we will start building our modules and proceed further. Alright, so now we have a proper working connection, and we have seen that we can send data from server to the victim machine and vice versa. So our next goal would be to expand further on that. For example, to create different features. Let's say you want to run a command on your victim machine. So what you can do is you have to send command from your server or hacker machine to the victim machine. The victim machine will execute this command on its own PC, and then you will get back the result to your main machine. So this is the whole kind of back and forth communication. So in this step we will try to achieve the same objective. So our first goal would be to execute a command on the remote system. In order to do that, we have to create a new file called handle connection, and in this file we will try to create a handler for this connection. You will see what I mean by a handler. So we will go to the core, and then we will create a file called handle connection. So handle connection.py. So currently I am on my server machine. So let's create a method called handle connection. And what this method is going to do is that it's going to take a socket connection which we created here in our main file. So this one, which is my socket object, and then it is going to repeat the same procedures inside this function so we can organize our code in a proper manner. So I'm going to call it my socket here, and then we can simply print a statement showing what this function is doing. We can say that handling connection. So now what we want to do here is that we want to create an infinite loop. So what this loop will basically do is that it will ask you for what you want to do again and again. So you don't have to start your program over and over again. I'm going to create an infinite loop here called while true. And then here we will ask the user for options. So first we will say select your option. So, and before entering it, what we can do is we can create a function here which will tell us which options do we have available. So our first option would be to execute command. So we can say define show options. This function will tell us our options. So I'm just going to copy it so I don't waste a lot of time. So first option would be to run command on the victim OS. So if we press 1 here, so it will send our input to the victim machine, and the victim machine will know that now we want to execute command on the victim machine. And then we can store it in a variable called user input. Once we have this user input, we can simply use this my socket to send data. So if I go to the connection, we have a function called send data, and it requires a user input. So I'm going to give the user input here. So my socket dot send data, and then I can give the user input as an argument. So now we should also handle this on our client machine, so the client machine receives it. So before I go to my client machine, I will remove these things, which is sending and receiving data, which we developed previously, and similarly I will do the same here. So I will go to my client and remove these two lines. Now I have to create the handle connection here as well. So I will go to the core and create a new file called handle connection.py, and now we will handle connection here. So we will create the function with the same name so we are consistent with our terminology, and then it will require my socket object. We can simply print here handling connection. So note that this is our server machine, but currently we are entering print statements here because we are developing our program. Once we complete our program, what we can do is we can remove these statements, and also you will see that we will create this file with no console. So when you will run this file, there would be no output on the screen, so the user won't know what is happening in the background. But currently, since we are developing, it is easier to see the output and see what is happening, so we can debug it easily if there is an error or something. And then we will create an infinite while loop here too, because since we have an infinite loop here, handle connection, so we have to create a similar loop here, so we are being consistent. So I will say while true, and now since we are sending data from the victim, is from the hacker machine, So our goal here would be to first receive this user input. So in order to receive it, I can simply use my socket object dot receive data, receive underscore data, and then I'm going to store it in a variable called user input. Note that I'm using the same naming conventions, so this will help us to create a better model for our code, and we will see what is happening properly. You can use different variable names, but then it will get confusing as your program will go bigger. So now we have a user input, so we can simply print it, so we can read it what is happening or what the user input. So we can say user input, and then we can enter the user input here. So note that this is currently an infinite loop. So if we don't put an exit condition here, this loop will continue indefinitely, and this can break our machine, and this can cause a lot of problems. So what we want to do here is we can put an exit condition here. So my exit condition would be, for example, if the value of user input is 99, I will exit my program. So I will say if user input equals to 99, I will say break this loop. Sorry, not breakpoint, break this loop. I can do the same on this victim machine as well. So if user input equals to 99, I will break it. So now we have a program that we can use to send data to the victim machine. So I will try running it, and you will see that. So now it's waiting for incoming connection. Actually, before connection, let's check what is the IP of this machine. So we hope it didn't change, but let's just to be sure. So I can say sudo ifconfig password. So it's 192.168.0.32. so if I go to the main client, so it is the same value here. So now this should work properly. So I can say python main client, and there is some error, I guess. No, there is no error. It established connection properly, but since I didn't print anything here, which is if I go to the handle connection, okay, so I didn't call my handle connection method in the main file. So what it did was that it accepted the connection, printed the statement, and exited. So now what we can do is from core.handle connection, we can say import handle connection method, and then we can call this handle connection method here and provide my socket as the object. And we can do the same on the client side as well. So I can say from core dot handle connection import handle connection, and then we will call this handle connection method here and provide my socket as an object, and then we can close this socket. So you can say my socket dot, okay, so close. So I don't have a closure method defined here, so I'm going to define it here. So let's say define close, and it is going to take self, and then we can say self dot close, self dot socket dot close. Close. So now we have a close connection here. So I can call this connection my socket dot close. Now it should go away. Now this should work, I think. No module named code dot handle connection. So what is the name? Okay, so it's handle capital C, not small c. Alright, so let's run this program again, and then this client machine. So now you can see that it says handling connection. So now we have to give the user input because it says select your options. If I go to the handle connection, you will see that select your options and then it is waiting for user input. So I am going to say 11. So now if you see user input 11, so and then it is asking me for input again. So whatever I input, it will go to the victim machine. So if I say 34, it has gone to here as well. So now if I press 99, this should exit. Now you can see that it has exited, and if I go to the Windows machine, you can see that it has exited here as well. So now we have a proper working connection that we can use to send commands. In our next lectures, we will build on top of it. Okay, so let's proceed further. So our next goal would be to try to develop a feature that will help us to run or execute our commands on our victim machine and then get back the result to our hacker machine. So first step first, so what we can do is let's go to this loop here. So actually before going forward, let's just call this show options functions here so we know which options are available to us, and then we can go on updating this function as we move along. So we'll call this functions show options here. And then our first case would be to run command. So we can say that if user input equals to 1, we can simply print out, for example, that we are running the system commands on victim. So instead of is, it should be if. And then we can say that else if user command or user input equals to 99, we can break it. And then instead of this condition, so we can say that if users enters an input which is wrong, we can repeat this whole process. So instead of this user input, we can simply remove it and say that else we can print out the statement that invalid input, and then we can remove this break statement. So now what will happen is that this program will continuously ask the user to provide inputs. So select the options, and then the user will select options, and first this option will be sent to the victim machine, and then the next step would be to check which option is it. For example, if the user is selecting to run commands, or let's say if the user wants to upload a file or download a file from the victim machine, etc. And then if the user enters 99, we can break it. Otherwise he inputs a mistaken value or something, we can ask the user again that he has entered an invalid input. So we can almost repeat the same procedure on our victim machine as well. So we can say, so here we are receiving the user input and then printing it. Then we can say if user input is equal to 1, we can print out a statement called running system commands, and then we will create a function here that will handle this execution. But at the moment I'm just trying to develop the skeleton, and then I will create more and more functions. And then similarly, if I can say that else if user input equals to 99, we can break it. Otherwise we can say that else, let's remove this, and we can print out a statement here that user input invalid. Invalid user input. So now we have a structure developed. Here we will create a function that will handle the create function that will handle command execution. And similarly, if we go to it should be print. If we go to the victim machine, we will call the function here, function that will run commands. So now we have our bare bones skeleton setup. So our next goal would be to build on top of it. So I'm going to stop here. Okay, welcome back. So now let's test if our program is working properly or not. So let's start our main server, and then I'm going to the Windows machine and starting. Now it says that handling connection, which means that the connection has been established properly. Now it says what options do we have. So it gives us an option of only one, which is run command on the victim machine. So if I press 1, you will see that it says running the command on the victim, and if I go to the victim machine, you can see that it selected this line, so it printed out this line as well. And similarly, if I give a wrong input, for example 4, you will see that it says invalid input, and it says the same on this side as well. So if we want to exit, we can press 99 and this will exit the program, and similarly it will exit on this machine as well. So now our program is working. So our next step would be to create this method which is running or executing system commands on our victim. So let's go to the core folder again and create a new file. Now we will call this file as running command. So I will call this command.py, and then here we will define a method, and this method will help us in running commands. Let's call this method define run command, and this will take my socket object as well. And let's just print it so we can know that it's running properly. Running command. Sorry for my typing mistakes. I make a lot of mistakes. Running commands. Okay, here what we can do is we can simply send out the command to the victim machine and get back the result. So first we have to know which commands are we working with. So let's go to the victim machine as well and repeat the same process here. So I'm going to create a file called command.py, and then I'm going to create a function called execute command or run command, whichever you like, and it is going to take the same mySocket object. Should be socket, and then I can say print executing commands, and then we can go to handle connection and import this function here. So I can say from core.command import execute command, and then I can call this function here execute command, and then give the mySocket object here, and then I can do the same process on my server side as well. So go to handle connection, import this, so from core.command import run command, and now we can, if user input is equal to 1, we can call this method which is run command and provide mySocket object. So in next lecture we will develop this program. Alright, so welcome back. In this lecture we are going to develop this program which is run command, and this will help us to execute commands on our victim machine. So first we have to get the user input. So currently I'm on my server programs. I can get the user input here by using input function, and then we can say that, let's say we put this double greater than signs, which indicates that we are in a kind of a terminal. So then we will store this value, for example, in a variable called command. So whatever command the user will input, we will store it in this variable, and then we will send it using this socket to our victim machine. So I'm going to call mySocket.sendData, and then I'm going to send this command. Then I have to get the results back, so I will use the same socket. So I will call mySocket.receive data, and then I will store this in a variable called result. and then I'm simply going to print this result. Or receive data, I think already does this. If I go to the connection and receive data, no, so it doesn't print it, so I can print it here. So I can say print result. This program will run command once and it will exit, but what I want to do is I want to continuously give commands and get back the results until I enter an exit condition. So I can put a while loop here, so I will put an infinite while loop. So I will say while true, and then I will put whole this thing inside this loop, and then I have to put an exit condition here, because if I don't put an exit condition, this will continue on looping forever. So I can say if command equals to stop, so we can say that if we write stop in our terminal, we want to break our loop, and similarly I can do the same process here. So first I will develop this function. So now I have to receive the command here, so I can say my socket dot receive data, and then I will store this in a variable called user command. And then just to be sure, I will print this command, so I will say user command. And then the next step here would be to take this command and execute on this machine. So we will do this in our next lecture. Okay, so now since we are sending the commands in a loop, so on the victim side we have to create the same loop and receive the files inside it. So I will create a loop called while true. So I will get commands printed and then check if the user command equals to stop. I can simply break my loop here, and if it's not the case, we will proceed further. So now when I receive the command, then next step is to run this command on the system. So in order to run it, we have to import subprocess. So I will import subprocess here. So this package helps us to run commands on our machine. So now I will use the subprocess module to call a method called run, and this method requires a list of commands. So since we want to run only this user command, so we can put the user command here. But before doing that, we have to specify which shell we want to use. Either we want to use the cmd command prompt or the PowerShell. So I'm going to use PowerShell, but you can use command prompt as well. So I suggest you use PowerShell as well. And then the next element would be the command that we want to test. So I will put the command here, and then we check if the command output has an error or not. So we can say we have to store this in a variable called output, and then we can check if this output results in an error or not. So we can say if output dot std error dot decode. So now this error in the form of byte, so we have to convert it into a string format so we can read it properly. So we can convert it into, so we have to use UTF-8 decoding, and then we will create a variable called command result and store this value. Okay, so now we can check that if there is no error, then we can simply print out the command results into our variable and then send this result back to our hacker machine. So in order to check if there is no error, we can say if output dot standard error dot decode, and then we will use UTF-8 decoding, and we can say that if this result is equal to empty string, which means that there is no error, we can simply say command result equals to, and then we will store the actual output. So we will say output equals to standard output dot decode, and then we will simply use the UTF-8 decoding here as well. And if there is an error, we can say command result equals to output dot standard error, and then we will print out the error dot decode UTF-8. So now we have either the result or the error, so whatever it is, then we have to send this to our victim machine. So we can use this socket, which is my socket. So I can say my socket dot send data, and then we can simply give the command result here. So now everything looks complete, so now we can run it. So I am going to send the data and receive the data. Okay, let's just run it. So I can say Python main server, and now it's waiting for connection, and then I'm going to run this client here. So now you can see that we have a connection. So now I will select the command execution menu, which is, if you go to the handle connection, you can see that it's this one. So oops, so I will press 1 and you will see that we are into running command mode. So now I can give the command. So if I want to check what are the files in my directory, I can press dir, and I don't get any result back. Why? Because there is an error. So it says command not defined, so it should be user command, not command. So I made a mistake here. And then I run the program again. So let's stop it and press 99 here to exit. So now it's broken because it couldn't establish the connection properly. So let's try it again. So now it's waiting for incoming connection, and now it has connected properly. So now I will press 1 and then I will write the command. So I will write dir again, and now again it is an error. So it says that standard error dot decode none type has no attribute dot decode. Okay, so there is another small error. So I have to set shell equals to true here, and also capture output equals to true as well. So because it didn't capture any output in this variable, so that was there was an error. So let's stop it here and press 99 to cancel it, and then let's clear this again and run this program. Clear the screen and run it. Now hopefully it should work. So I'll press enter, and when I press dir, now you can see, if I open the terminal again, you can see that I get a proper result which says that I have these files. Now I can run multiple commands here. So if I write pwd, so it will give me present working directory, and if I write dirr, which is a spelling mistake, now it should give me an error. So it gives me a proper error and it didn't break the program. And if I want to exit, I can say stop, and then it will go back to the main menu, which is defined by this handle. Where is it? So which is defined by this handle connection. So now it is in this loop. So this is how you can execute commands on the victim machine. I will stop here, and in next lecture we will proceed further.